Okay, so I want to go over exponential growth and decay. So we had started talking about, we had the two, so exponential growth versus exponential decay. So I want to take a moment, so looking at that exponential growth and exponential decay in your real life examples. Okay, so the formula for exponential growth is a times 1 plus r to the t power. Oh my goodness. There we go. And here's exponential decay, and decay is a 1 minus r to the t power. Okay, so let me go through and kind of help you. Okay, so what we have here, exponential, we're going to start with decay. Just because, sad face, this is about you losing money, okay? Decay. So this is the amount of money that you spent on an item, okay? This is the rate at which it depreciates. So if you ever hear that word about depreciation, that's what we're talking about. And T stands for time. And in depreciation, it's usually in years, okay? That's in years. So let's take, for example, a cell phone. Okay, so you just bought a new iPhone for $800. Okay, and I looked this up, and an iPhone depreciated at about 56%. So 56% is what in a decimal? Yeah, 0.56. And we want to find out how much that cell phone is going to be worth in 1 year. So on your calculator, you can actually plug this whole thing into your calculator. So 800, 1 minus 0.56. Okay, and you can even go to the first power, but anything to the first power is going to be the same, so it really doesn't matter. And it is $352. So holy mackerel. So after 1 year, wow, that's kind of depressing, isn't it? So you spent $800 on a cell phone that in a year is going to be only worth $352. Now, when you stop and think about that, I just bought my new cell phone this year, and I'm on a payment plan. That payment plan it's going to take me 2 years to pay for my phone. Wow, even after 1 year, it's not even going to be worth that much. And the other thing to think about is that I looked up in cell phones. So let's talk about stuff that depreciates. Cell phones, super depreciation, anywhere from 36 to 76% depreciation rate. That's crazy. You know what else depreciates? Cars. The minute you drive your car off the lot, it is not going to be worth what it did when you bought it brand new. This is why buying a brand new car maybe isn't in the best interest. Another one, TVs. Holy mackerel. Those big TVs that people had before we went digital are worth nothing now. Okay, absolutely nothing. Think about like TVs. How about a VCR? Okay, VCR, what's even that? You know, people have Blu-ray players. I mean, that's crazy. So the depreciation, and some people even talked about your house. Houses can depreciate. It really depends if you stay up on upkeep of your house sometimes, and also what the area houses look like in comparison to yours. So this depreciation, yeah, sad face. This is stuff is not going to be worth as much. And again, it's usually over a period of 1 year is depreciation rate. So you'll have to look at this because especially cell phones. That has been especially crazy. Okay. Which is why a lot of times, the deals on trading in your cell phone are not as great anymore because who wants your cell phone? I had my last cell phone was I had it for 12 years. Okay. It was absolutely worth nothing. And don't even get me started on my dad's flip phone. Okay. All right. Let's talk about growth. Growth is a good thing. This is making money. Okay. So let's say that I had $1,000. Okay. And I want to put that in the bank. Unfortunately, I'm only going to get about, oh, sorry. This is money you put in. Here's your rate of interest. Okay. And this is time, and this is in years. But there's something else that we need to talk about with this. I'm going to put this off to the side. We also tend to calculate interest in some different periods of time. It can be daily, it can be monthly, it can be quarterly, or it can be yearly. Okay, so these numbers, these are going to go underneath and divide out your rate. These are also going to get multiplied by your years as well. So that number is going to go. So if it's daily, it's 365. If it's monthly, it's 12. If it's quarterly, there's 4 quarters in a year. And if it's yearly, it's 1. So your interest can be compounded daily, monthly, quarterly, or yearly. Okay, so let me give you $1,000 is your deposit. We put it in the bank for 1% interest, compounded. I'm going to do daily. Okay, so I'm going to take 0.01 because that's 1% and divide it by 365. And I'm going to do it over 5 years. Okay, I've got some money. I'm going to set it aside for 5 years. Okay. So you see this? I had to take that. Not only did I have to put that here, but I also had to put it up there. Now that looks really, really yucky as a problem, but you know what? It's really easy to put in on your calculator. So are you ready? I'm going to put 1,000 in and I'm going to calculate. And I'm going to use parentheses wherever I can. Okay, do you see what I just did? So 1 plus, and then I put in parentheses just that division piece, then close the parentheses. Then I'm going to take it to the power of, and I'm going to put that in parentheses as well. Because if you don't, things could get a little messy. And then I'm going to hit equals, and I should come up with a number that's going to be bigger than $1,000 because I'm hopefully making money at that bank, right? So $1,051. Let's round to the nearest penny. So go 3 places. So that's a 0. So 27 cents. Huh, that's not so much, is it? Well, stop and think. First of all, it's really not about that you only deposited $1,000. You really only made a 1% interest. Okay? Sad face, friends. 1% interest, you're not even getting that in a savings account, okay? In fact, I think in most savings accounts, and I have to look at Frankenmuth Credit Union, you're making like 0.1% interest. That is actually 0.001 when you calculate. That's pretty terrible. You're making about as much as interest as you would if you hid your money under your mattress, okay? Something that would make you more money is going to be called a CD, which Frankenmuth Credit Union has great rates out there. But again, you have to usually lock your money up. And the longer you go, the higher the percent. Okay, so for example, if you locked up $10,000, you might get and you did it for 5 years, you might get a 6% interest rate. But when you stop and think about it, you right now in your lives don't need to be locking up money like that for 5 years. Right now, you're getting ready to go to college. So you locking up your money is not good, because if you pull that money out before the end of the 5 years, you'll get a penalty. So nothing is really making great money right now. And the sad part is that your depreciation rate will always be higher than anything that you make. So sorry to leave you on that note, but this is what we're focused on. So there was a problem on Big Ideas, okay? And on Big Ideas, it said a car, and this was in thousands. So 25 really stands for $25,000 car. And it gave the formula like this, okay? And it asked, is this a growth or decay? Okay, and the answer here is, because this is less than 1, this is a decay problem. So this was a depreciation problem. And then it asked, what is the percent of depreciation? Like, well, let's go back to the formula. I'm going to write what I have here. And then I'm going to write the formula underneath. All right. So 1 minus what gives you 0.85? 1 minus what gives you 0.85? Well, if you do that, you soon realize it's 0.15. What is that in a percent? Well, that's 15%. So your depreciation rate is 15%. They just went and calculated it out. They didn't show you that. This is the same as if they wrote out the formula like this. Okay? And then the next question asked, hey, when is the car going to be $8,000? Well, you know, we don't have, and somebody brought it up that we thought it was on FIM, and it kind of was. So we don't really have a method to solve for T just yet, but we're going to put this in on our calculator, okay? And on our calculator, I'm going to go ahead and I'm going to put it on, put it in my Y equals. So see how it's in my Y equals button? And I'm not going to graph it. I'm going to go to the table. And remember, this is in thousands, okay? So where you see, see, 0, 25, that's $25,000 when you bought the car. So after how many years? So let's look, where do we get 8? Right there, year 7. Year 7. So by year 7, your car, your $25,000 car is only going to be worth around $8,000. Okay? So 7 years. Which is kind of funny. How many of you are driving a 7-year-old car? I know I am. So this is why when you go to trade your car back in, it's not as worth as much because of depreciation. Okay, thanks, friends.